Hi all. Today we are going to discuss about the topic database management system. We all know that for a developer point of view, data is the major concern. Data management, data security, data use, everything is a major concern from a developer or programming point of view. Coming to database management system. Simply, database management system is a software to manage all this data. There are several another dimension for the database management system, but simply database management system is a software to manage all this data. What are the major concerns when managing all this data? First one is collection of interrelated data. For example, for a library management system, we are having all this data regarding the users, all this data regarding these books, all this data regarding the transactions, book transactions. For a banking application, we are having so many data regarding all this money transaction, all these uses, all these loans, all this deposits, everything. All these are connected data, connected interrelated data. And then coming to access to this data. In the early times, we were using procedural languages. Coming to recent time, we are using object-oriented programming concepts. We have to access data in more secured way. This is the major concern for a developer. That is coming under access to data. And DBMS is a software which is used to manage, access, and manipulate all this complex data. Come to the database management system application. First one is banking. For considering a bank, we are having lot of transactions. Transaction from the users, transaction from the internal banking employees, transaction from parent bank, etc. We are having so many transactions. Nowadays, we are having ATMs also interconnected to the bank server. So we are having so many transactions from so many entities. Coming to the airlines. Airlines reservation, schedules, cargo movement, everything is coming under this database management system. Universities, sales, manufacturing, human resource database is coming under all these scenarios. Why? Because all this data should be managed efficiently. Then only we can rely on that particular data. Otherwise, we will have to write all this data into hard copy. But the major factor in this database management system is the reliability of that data. Then only we can completely believe what data is saved. For example, for a university, we are saving all the students' mark and details in a particular database. We are not having any reliability. We cannot print certificate from that particular data. So database management system software must focus on some of the real solutions. So it must deal with some of the problems also. So in this section, we are going to look on how a database works and what is the structure of a database and what are the features of a database and some of the real world problems which is solved by database. In order to understand what is database, we have to focus on earlier file system. Let's have a look on file system. Coming to the earlier days, database, all this data management was done over files. So we know files in the real world life. We have to keep each data in separate files. In order to search a particular data, we have to first open each file and identify which one is the real file. After that, we have to search on particular files. This was the major time-consuming process happened at that time. And the drawback of using file system to store data. First one is redundancy and inconsistency. That means frequently some of the data are redundantly available in these files. Second one is inconsistency. Some of the data are not consistent, which decrease the reliability to that file system. And multiple file formats. Multiple file formats is a major drawback in managing this file system efficiently. And difficulty in accessing data. As I mentioned earlier, if you are having huge set of files, it's very difficult to access a particular data from the file. And then coming to new programs. For example, if you want to take particular data from the file, we have to write new programs for that particular process. If you want to take particular data in some another format, we have to code again in that particular manner to get particular data. These are the major drawbacks in file-based database systems. Coming to the recent problems that is solved by this database management system. First one is atomicity. As you can see, atomicity updates. That is, for a banking concern, each transactions are crucial. For example, if I am going to a particular bank and depositing 10,000 rupees, that 10,000 is very valuable to me in real life. That 10,000 without 10 is 1,000. I am updating that data in a database. If I am updating it as 1,000, next time when I go to bank, that time I realize I lost 9,000 rupees. That is, partial data updation is a serious issue in real life. Atomicity is the major solution for that. That is, a transaction must update either completely or no transaction should be happen. That is, partial updations is not supposed to do. That is the term known as atomicity. Coming to concurrent access. Concurrent access is another performance improvement in DBMS. That is, we are having so many ATMs, so many banks, so many net banking facilities, applications are there. There may be two persons accessing the bank same time. Nowadays, millions of people are accessing the bank same time. So, concurrent access is the major factor, major performance improvement that is focused by the DBMS. Then, uncontrolled concurrent access. There is a major concern. That is, concurrent access is a feature, but it should be controlled and it should be managed properly. Then only it can be considered as reliable. Otherwise, it leads to inconsistent data. Then, coming to an example, when two persons are reading a particular balance. Just an example. Suppose I am reading a balance. I got it, my balance is 10,000. But there may be some another concurrent data is happening. Maybe there is some loan premium is there. That data will be minus by that loan premium. So all this data must be consistent. When I am reading at that particular time, all this data must be consistent. Otherwise, I will get some another value and the next time when we check, there is another value. So all this data must be considered properly. Coming to just one small structure for a database. It's a three-layer structure, as you can see. First one is view level, logical level, and physical level. What is physical level? Physical level means how all this data is stored. For example, customer data is stored in accordance with the physical level structure. Logical device and logical level describes data stored in the database and the relationship between particular data. And coming to view level. View level means all these applications which relay over this structure. There's application, there may be GUIs, etc. All these come to view level. And this view level is completely different and completely separated from logical level. So the end user is not able to come to the background of what is happening in behind this DBMS. Coming to database management system. Some of the key terms in database management system. First one is schema. Schema means the logical structure of a database. There are having so many structures to save data. Schema means the logical structure, how this data are organized in a particular database. That is known as schema. Example, for example, there is a data for customer management. There may be data stored in rows and columns. That data schema is known as relational database. Then, analogous to type of information variable in a program. Then, coming to physical schema. This is the data stored in the physical level. And coming to logical schema, database design as the logical level. All these schemas are very much important in database design. And coming to database management, logical schema. How this data is defined in the logical level. As I mentioned earlier, all this data, for example, customer management. Customer data has to be arranged in a structure. It should be managed, interrelated in a logical schema. And coming to instance, we have to take a particular data for a particular time. That moment is known as instance. For example, the actual content of database at a particular point of time. For example, this customer data. If I am taking the customer salary customer, how much amount is the customer paying to our company. At that time, that value comes out, and that is known as a particular instance. And physical data independence. Physical data independence means the ability to change the physical schema without changing the logical schema. Just we mentioned about the schema. In this physical data independence, it means we are completely separated. This physical data and logical level is completely separated. We can change the schema without interfering the lower level. That is the logical schema. And application depend on the logical schema. Then coming to, in general, the interface between the various levels are completely separated. So we can change any of the schema at any time. And this is an example for relational database. Here you can see customer ID, customer name, customer street, and customer city. We have so many data also. We are having almost 7 rows of data. Here we are considering each columns as attributes. Customer ID is an attribute name, customer name is an attribute name, customer street, everything is attribute name. And we are considering each row of data as tuples, T-U-P-L-E-S, tuples. And we are having so many data also. This is an example for relational data model. We are saving this data into a database, so it is known as relational database management system. So the database management system is a software which is to manage all this data, and relational database management system is a software which manages all this data in a relational data model, that is data stored in the rows and columns. And these are the key concerns, key features in database management system. First one is DDL statements. As I mentioned in just a few slides before, we are having so many schemas, so many logical schemas are there. We are applying this kind of DDL statement, DBL, and the SQL statements to this particular schemas to manage all this data. First one is DDL statement. DDL means data definition language. Some of the examples are alter, drop, create. We are applying these queries on our data. DDL is used to change the conceptual level of our database. For example, if you are supposed to change this column, if you are supposed to change, alter, add another column, another attribute, we can use alter. If you want to drop this entire table, we can use drop command. Like that, if you want to change any of this schema, we can use DDL statement. We can manipulate all this structure by using this DDL statement. In effect, we are changing the concept schema by using DDL statement. Coming to DML, data manipulation language. Some of the examples are update, insert, delete. Simply, the name specifies data manipulation. That is, if you want to change any of the data, delete data, or update any of the data, we can use data manipulation language. Coming to the SQL statement. SQL is structured query language. That is the major feature of database management system. In earlier times, we were in file system, we were writing separate programs for separate activities. But in SQL, we are having this query language. So by using DML and DDL statement, we can implement different actions at different times. We can manage our logic, we can change our logic based on the requirement. Simply by using these SQL statements. This is the major advancement in database management systems. Coming to DBA. DBA means database administrator. The whoever person who is managing this database, he is known as DBA, database administrator. There are some various job roles for DBA also. Database configuration, database access, stored procedure language, and stored query language management, everything. All these are done by DBA. So DBA is an important role in database management system. So these are the main concepts in database management system. But database management system is a vast area. We have to focus on different database structures also. Here I just mentioned one concept schema, that is relational database. But there are so many structures available. For example, Facebook. We are using Neo4j in Facebook, but it's saving data in node graph structure. Like that, different database environment is having different structures. So let's have a look on database management system. Database management system is a software which is used to manage data, as well as DBM is having so many security features, so many data efficient mechanism to retrieve data from that. Thank you.